2 days before Hurricane Maria devastated Puerto Rico, a NASA satellite captured a 3D view of the storm, revealing the processes inside the hurricane that would fuel the storm's intensification. NASA's precipitation satellite has an advanced radar that measures both liquid and frozen water inside hurricanes. This satellite is called the Global Precipitation Measurement Core Observatory, or GPM. Now, for the first time, we can take you inside a hurricane in a 360-degree view of this data. You can look around by moving your device or clicking and dragging on the screen. We're currently inside Hurricane Maria when it was a Category 1 hurricane in September 2017. This was a few days before it rapidly intensified to a Category 5 hurricane. Look down and you'll see a map showing where we are inside Hurricane Maria and what the colours are showing. The dots around you show areas of rainfall, where green and yellow show low rates and red and purple show high rates. The coloured areas below the dots show how much rain makes it to the surface. Look up and you'll see blue and purple dots that show light and intense frozen precipitation. Right now, we are travelling through a gap between rain bands. Now we'll collapse the clouds of dots into the actual data values, which are in millimetres of precipitation per hour. The rates in this storm vary from less than 0.5 millimeters per hour to over 150 millimeters per hour. It's these actual values that scientists use to figure out what's going on inside hurricanes. Next, we'll turn the numbers into a representation that helps us to see other 3D structures in the distance. Wider red and purple ellipsoids show higher rainfall rates, and spherical green and yellow ellipsoids show lower rainfall rates. Rising to 5 kilometers, you'll see a distinctive change to frozen precipitation shown in blues and purples. This transition is the melting layer, where falling snow and ice warm to the point that they melt into water drops. We are currently moving up a tall column of intense precipitation. Scientists call these hot towers. Lots of heat and energy are released in hot towers as rising water vapor condenses into precipitation. Most hot towers are between 10 and 15 kilometers high, roughly the altitude that commercial jets fly. Multiple hot towers are common in intensifying hurricanes. Here's another hot tower that's about 17 kilometers tall. Hot towers often appear near the eye wall, a ring of heavy wind and rainfall surrounding the center of the storm. We're now in the eye of Hurricane Maria. At this stage of development, Maria's eye wall is asymmetrical, with heavy rain in the northern part coloured in purple. This is common in storms impacted by environmental winds. A few days after this time, Maria's eye wall intensified and became more symmetrical. While NASA's GPM satellite can detect big features like the shape of the eye wall, it can also measure tiny precipitation particles. These blue drops show the size and density of ice and water particles inside Hurricane Maria, which is also known as drop size distribution. Big drops are coloured in dark blue and small drops in light blue and white. Looking at drop sizes and rainfall rates provides a key part of the equation in understanding hurricane intensity. Factors such as temperature, humidity, wind speed, and clouds influence the size of the precipitation particles, which in turn affects how much rain falls and how a storm grows. These advanced satellite measurements are critical for improving forecasts of how these powerful storms may intensify and where they may go. Scientists are seeing things never measured before, revealing new insights into hurricanes, drop by drop.